Right. Okay. So we are on to Euclidean geometry, circle geometry, and we are going to start with Theorem 1. There are 9 theorems that we will cover. Theorem 1 is one of the ones that you have to prove. Okay. So some of the theorems you need to be able to do the proofs, at least while you're doing pure math. Technical math, you need to know them as well, but you don't need to prove them. Pure math, there are 4 out of the 9 that you will need to prove, this being one of them that you do need to prove. Okay, so whatever we produce in this video, you need to be able to produce on your own. Okay, so what's given on the picture is given to you. In fact, they will also indicate that angle B over here is 90 degrees. Okay, so this is given to you. Anything that's not given, I'll throw in a different color. Okay, so everything that you see currently on the screen, they tell you O is the center. They say AC rather is a chord. So what's a chord? A chord goes from one point on your circumference, straight line, to another point on your circumference. That's a chord, right? The only difference between a chord and a diameter is that the diameter goes through the center of your circle. Your chord doesn't go through your center. Chord is from one point on the circumference to another point on the circumference, right? So AC is a chord that's given. O is the center that's given. OB is drawn onto the chord so that OB is perpendicular to the chord, right? So this 90 degrees is given to you when you need to draw or determine the proof. Okay, so the first thing that you're going to do when you do the proof is you're going to do a construction. That means you are going to draw something in that's not there. So you're going to draw AO. That's a construction that you're going to draw. Also, you're going to draw in CO. So those two lines you've drawn in. Okay, what you should know also that both of these are radiuses, right? Or radii. The plural for radius is radii. So those two lines are radii, meaning that they are equal. A radii, a radius, is from the center to the circumference. Okay, so OA, OC. Let's write that down. So you also need to produce this. So let me maybe put this in black. You are going to say that AO is equal to CO, and you're going to say the reason for this is radii. Great. Okay. So now also what you do know is that because of your construction, there are 3 triangles formed, right? OAC or OAB, rather, that's one of your triangles. OCB, that's another triangle, and yes, a third triangle, ACO. Those 3 triangles are formed. Okay, let's leave that one there for a moment, because what we can see from that triangle that is currently there, right? Um, these two lengths are equal, so therefore it's an isosceles triangle, and if it's an isosceles triangle, this angle and this angle are the same. So let's write that information quickly. I'm just going to erase the things that I included that you don't need to include. So whatever you still see there is your construction. That is what you need to produce. Okay, so we said that angle A is equal to angle C. The reason we know that is because that's an isosceles triangle, but that's not the reason we write in our brackets. In our brackets, we'll say angles opposite equal sides, right? So that is the valid reason when you have an isosceles triangle and you are given that the sides are equal and you proving that the angles are equal. Your reason is angles opposite equal sides. Okay, so we have the radii, that's the same. We have the angles which we've proven now, and then also we could look at this line over here, right, which was given to us. That line is OB, so we'll say OB, and that is common, right? So we understand what that means, and to say that it is common is to say that it exists in both of your triangles. So OB, it exists in AOB, and OB exists in OCB. Okay, great. And with these 3 statements, what do you know, right? So this one over here, this is a side. This one over here, this is an angle. This over here is a side. I want to say angle, side, angle, side. However, I can't really use that reason, because in order to use that reason, we need an inclusive side angle. So the angle needs to be in between the 2 sides that you've got. So let's rather look at this given information over here, that 90 that was given to us, right? So let's do this. We'll say A, B, O. that angle is equal to CBO, and both of these are equal to 90 degrees. How do we know that this is 90 degrees? This was given. All right, so here we have our right angle. Okay, so now what the reason that we are going to use is we're going to use the right angle, we're going to use the hypotenuse and our common side. So we are going to say triangle ABO is congruent, and congruent is three horizontal lines like that, right? To triangle CBO, and our reason is right angle hypotenuse side. Great. So we've proven congruency. Now let's just go back to this image here. What does congruency tell us? Congruency says everything is the same, right? So this angle is equal to this angle. We've proven that. But because we know it's congruent, we know this angle and that angle is also equal, and this angle and that angle is also equal. That last one was given, but our congruency tells us all of our angles in the one triangle correspond to all of the angles in the other triangle. Similarly, the sides, because of our congruency, we know this one and this one is the same. We've proven it with radii. We know this one is the same. We know that already because it's common, but then we'll also know that AB and BC, that is the same. Okay, let's get rid of all of these extra things that I drew now. Okay, and that last piece of information that I mentioned, that is the important deduction from this theorem. So what is the important deduction? It is that AB is equal to BC. That's what we want to know. So after we've proven our congruency, now we know that AB is equal to BC, and that's what theorem 1 tells us. Okay, so theorem 1 tells us this: when you have, let's erase all of the extra stuff that we've included. Okay, maybe I'm erasing too much here. Okay, I'll throw in the rest. Okay, so when you have a line that goes from the center that is perpendicular to your chord, okay, so you know that this is the center, this line is perpendicular to your chord, then you know that these two are equal. So that perpendicular line bisects your chord, okay, and when we use this reason, what we will write down is we'll say line from center. So remember, we need our reasons. Our reason will be line from center perpendicular to chord. Right. So when you have a line from your center that's perpendicular to the chord, you know that that line bisects the chord. Okay, so that means this line are equal to each other. Why are they equal? Because this line is perpendicular to your chord. That's theorem 1.